Okay, welcome to Unit 3, Part 1 lecture. In these lectures, we are going to cover the frequency distribution. We're going to cover the frequency distribution. Frequency distribution was question number 1, and 1A and also B is about graph. So a question is given to us and they give us a data and they tell us to create a frequency distribution. The concept of a frequency distribution is how the data is organized. So for example, I have a large data set, let's say about number of employees, let's say 100 employees with different annual salary. Now, if I have all of them separated, listed, I may not know which employee may have the highest salary or the lowest salary, unless I go through each of them. Or if I want to know how many employees make some large amount of income or between some range of income, which means I have to go through all the list of the employees' salary. So we can plot a frequency distribution that will make us fast to know. Let's say we have employees making salary from 10,000 to 100,000 a year. We want to know how many employees make between 50,000 to 60,000. I don't want to go through all the 100 employees list. I can plot a frequency distribution and directly I can know the amount. So frequency distribution helps us to organize our data set in a short way. It helps us to organize our data set. So our objective here again is a frequency distribution. And this is an example. So here we have a table with two columns. We have the first column is class, the second column is frequency. So class will be, let's say if it's employees, okay, I want employees that make salary between 10,000 to 20,000, that would be one class. Maybe from 20,001 to 30,000, that would be second class, etc. So our data set here given to us, we can see that we have a data set, maybe the minimum value is somewhere 1, the maximum value is 30. So we were able to come up with a class. When you are creating your class, the size, or I would say the width of the class have to be the same. So we can see here from 1 to 5, 6 to 10, 11 to 15, there's 5, 5, 5, 5 difference between. So the intervals of each class is the same till the end. So here we say the table that shows the classes or intervals of a data with a count of numbers of entry in each class. So within the class 1 to 5, we have 5 entries. So frequency section will be like the total tally, the number of, let's say if this is an employee, then we say we want to know the employees that make between $1 to $5. Here we say 5 employees make that amount, between 6 to 10, 8 employees. And the total amount here will tell us the total employees we have. So for example, here we have 5, 8, 13, 19, 19 plus 8, 27, plus 5 will be 32. So here I will say the total employee we have is 36. So again, frequency distribution, the main concept is to organizing our data. So this make it easy for me. Let's say if I want to know the employees that make between $16 to $20, I'll say it's only 8. I don't need to go through all the 36 employees list. So a frequency F of a class is the number of data entries in the class, so the total tally, which is our second column. So we have the lower class limit for each class, 1, 6, 11, 16, 21, 26. So these are the lower class limit. And we also have the upper class limit, 5, 10, 15, 20, 25, and 30. And the class width, always we can find the difference between the two lower class limits. So 6 minus 1 is 5. Then we can say the same thing. Let's go through. The same thing, 11 minus 6 is 5. 16 minus 11 is 5. 26 minus 21 is 5. And when I go to the right side, the same different answer we should get. The difference of 10 and 5, difference between 15 and 10, So that's what we mentioned earlier. The class width or the class size have to be the same for all the classes. So how do we construct a frequency distribution? We should follow these steps. And the first previous, we just see the example, but how do we construct it? First thing we do is to decide on the number of classes. So sometimes the question may be given to us and they will tell us the number of classes. So the number of classes can be somewhere between 5 to 20, but again, when the question is given to us, the number of classes will be given to us. Or if the number of classes is not given, then we should just assume, we should just make our own assumption. Okay, I need 5 classes, 6 classes, 7, that should be enough. But most of the time it should be given to us. So usually between 5 to 20, otherwise it may be difficult to detect any patterns. So by default, somewhere 5, 6, 7 is enough. Again, it will be based on the number of data you have or the values range. Now, the next thing we do, if we know that we need 5 classes, now we have to find the class width. In order to find the class width, we have to know the lower value and the maximum value. So this is where we determine the range of the value. So the range of the value is the difference between the highest value and the lowest value. Then when we find the range finish, we divide the range by the number of classes. So that's the formula of finding the class width. Determine the range of the data. The range of the data is the difference between the highest value and the lowest value. Divide by the number of classes that we decided we need. Now, if your answer is, for example, 3.1, make it 4. If your answer is 2.9, make it 3. If your answer is 4, that's great, leave it 4. So what I'm trying to say is that when you find a range, the difference between the highest and lowest value, and you divide by the number of classes, if your answer is decimal, always run it by 1. So even if it's 4.011, make it 5. If it's 4.999, make it 5 also. So that's what we say, run up to the nearest convenient number. Always we have to run it, not approximate. Approximate means if it's 4.2, we leave it as 4. If it's 4.5 or 6, 7, we make it 5. But run up means if the decimal is 0.0001, we still make it. Let's say 3.001, I'll still make it 4. Then the third step, we have to find the class limit now. So it's up to us. Most common way of doing this, use the minimum data entry as your class limit value, the lowest value. So here they say you can use the minimum data entry as the lower limit of the first class. Or you make, let's say if the minimum value is 7, I can decide to use 5. If I know the class interval is 5, 5, and I want to get 0 and 1, I mean 0 and 5 between, let's say, from 0 to 5, from 6 to 10. In this case, instead of starting with the minimum value of 7, I may start with 5. But always we have to start with the minimum value or less than the minimum. If we start with a value that is greater than the minimum data entry, of course, then we are going to lose that value. So you can use the minimum data entry as the lower limit of the class or a little bit lesser value. Then we have to find the remaining lower limit class, which means we have to add the class width to the lower limit. So that's what we saw the difference previously. We saw the difference between 2 lower limits will give us the class width. So let's say if I decided to use 5 as the class, starting with the class lowest limit is 5, which is the first class, and I already find the class width. Then what are the class width again is the range, which it was step 2. The range of the value, which means the difference between the minimum value and the maximum value divided by the number of classes. When I get the value for the class width, now what I'm going to do is to add that value to each of the lower limits. So if I start with 1, if it's 5, the next will be 6, the next will be 11, the next will be 16, then you keep going. So here they say you can use the minimum data entry as the lower limit of the first class or a little bit lesser value Then also find the remaining lower limit by adding the class width to the lower limit of the preceding class. So if the classes are 5 and I start from 1 and the width is 6, then I'll get 1 plus 6. The answer I get 7 plus 6, 13 plus 6, 19. So those are all the lower limits to the end of the class. Then we go to the upper side. Now find the upper limit of the first class. Remember the classes cannot overlap, which means I cannot say, okay, from 5 to 10, then from 10 to 15. You can see that the 10 will fall in 2 different classes. We don't want that. We want each value to belong to only one class, not more than one. Then we find the remaining upper class limit. Then the next step, we finish with the first column, which is the classes. The next step, we go to the second column, which is the frequency. The frequency section, we just make a tally mark for each data entry. So we just count how many data entry fall on each classes. We just, again, count it. Then after we count finish, we again put the value down for each class. Now let's see this example. Hopefully this example may explain all the steps for us. So here they say, the following sample data set lists the number of minutes 50 internet subscribers spent on the internet during their most recent section. So here I have 50 internet subscribers, and the data we have there is how many minutes each of them spent. Now we can see here, okay, I want to know how many subscribers spend like less than 30, excuse me, less than 30 minutes. This means I have to count. I have to go through all the lists. This will take a lot of time. Imagine if we have over, let's say, 3,000 internet subscribers. So this is the reason of using frequency distribution. My goal here now is organize this data so that I can easily, again, determine the class range, etc. So as we said, the first thing we have to know is the number of classes. In this question, luckily they gave us the class. They say 7. Construct a frequency distribution that has 7 classes. Now, if 7 classes is not given, I may choose somewhere between 5 to 8. It should be okay because here we have only 50 internet subscribers. So if it's 7, then we know our first step already. Now the second step is to do what? Is to get our range. The range means we are going to look for the lowest value and the highest value here, which the minutes. Find the difference of the two, and that will give you the range. Then we divide by 7. When we divide by 7, that will give us the class width. So finding the class width means find the range of the data set. Range is the maximum value minus the minimum value. Then we divide by 7, and that will give me the class width. So that's the first step here. The number of classes is 7. It's already given to us. Now here we say find the class width. So the class width means maximum value minus minimum value divided by the number of classes. So that gave me 86 minus 7 divided by 7. When we use the calculator, we approximately get 11.2 now, 29. So I have to round this up to 12, as we said earlier. So now if I have the class width, next thing I want to get the lower limit value for the first class. Now, most of the time, as we said, we can use the lower value. I can see the lower value here is 7. But if I want, since I have 12 here, maybe I don't want to start from 7 to 19 and 20 to 20. So if I like, I can start somewhere with 3. And I'll say, okay, from 3 to 12. It's up to us. It's up to us where we start our limit value. But most of the time, we can go with the 7 or so. We are not. The only thing we can start with 8 or any value greater than 7. Otherwise, we are going to omit 7 from our frequency distribution. 7 will not be included, which means instead of 50, if we have only one 7, that means we have 2 7 here, 7 and 7, which means we are going to enter only 48 subscribers instead of 50. So we have to at least start with 7. So here we decided to start with 7. We know the class width is 12, so we had 12 to 8, that's 19. I'll add another 1231, another 1243, another 1255, another 1267, another 1279. We need 7 classes. So this is 1, 2, 3, 4, 5, 6, 7. So this will be my lower limit. Now we have to find our upper limit now. So if I move from 7 to 19, I should end here with 18. So automatically, we said we don't want our data to be overlapped, which means we don't want one value to fall in between at least 2 or more classes. That's too much. Each value have to be within only one class. So there's no overlap here. It's very straight. Since I have 719, how do I get from 7 to 19? Because the class width is 12. How do we get the class width to be 12? There's a formula to find the class width, which is again the maximum value of the entry, the data entry, minus the minimum value divided by the number of classes. That gives us something somewhere around 11.09. We run it up to 12, so we have 12. And the minimum value is 7, so we start with the 7. So 7, 12 is 19 plus 12, 31 to the end. Now the upper limit is more easy because I will look here 90. Okay, so I have to end at 18. This is 31, so I have to end at 30. This is 43, so I have to end at 42. And the list goes 67, I end at 66, 50. And if you find the difference of all this, you should still get 12. So the class width here, we check 30 minus 18 is 12, 54 minus 42 is 12, and the same thing, 31 and 42 is 12. The difference of 31 and 90 also is 12. So now we finish with the class, and I think this is the hardest part in the whole frequency distribution, because the frequency is just to count the tally. So now we move to the next step. We have the tally. And look at the data entry. How many subscribers spent between 17 to 18 minutes? They were 6. 19 to 30, they were 10. 31 to 42, they were 13. 43 to 54, they were 8. 55 to 66, they were 5. 67 to 70, they were 6. And 79 to 90, they were 2. Now, when I had all the frequencies, I should get 50. So as I said earlier, the higher the complex part of frequency distribution is coming up with the classes. And I think it's a very straightforward method. First, you should know the number of classes. Secondly, you should know the minimum and the maximum value. So the difference of the minimum and maximum will give you the range. You divide it by the number of classes, and that will give you the class width, which will be, in this case, we get 12. So we also have something we call determine the midpoint of a class. The midpoint of a class would be, for example, I have between 7 and 18. I'll find the average, and that will be the middle of the class. So it will be the lower class limit plus the upper class limit divided by 2. So we can see the lower class limit is 7 plus upper class limit is 18. That gives me 35 divided by 2. And that should give me somewhere around 12 or 35 should give me 17.5 or something. So sorry, 12.5. So 7 plus 18 divided by 2, 12.5. And then 19 plus 30 divided by 2, 24.5, 31 plus 44. So the midpoint basically is you are finding the average between the lower and also the upper class limit values. So 7 and 18, 19 and 30, 31 and 45, all divided by 2 to give us the average. And even when you find a difference between 12.5 and 24.5, we should get 12 because that is the class width. The same thing, 36.5 and 24.5, you should get 12. So the class, even with the midpoint, the class width will remain the same throughout. Also, we can determine what we call the relative frequency. Relative frequency is like finding the proportion of something. So we know the frequency already. We know between 7 to 18 is 6. How do we get a 6? We count the number of internet subscribers who spend between 7 to 18 minutes, and they were 6. Now, if I want to find the relative frequency, then I'll find the proportion, I'll say more or less like percentage. So I'll divide 6 by the total. Remember, the total is 50, so we divide 6 by the total. That's why here they say relative frequency is the class frequency divided by the sample size. So class frequency 6, the sample size is 50. So we get 0.12. Here 10 divided by 50, 13. So when you find the relative frequency for all the 7 classes, the total answer will be 1. Then also we can find what we call the cumulative frequency. Cumulative cumulative means always we are adding the previous value to it. So since we know frequency is 6, the next will be 6 plus 10, so 16. The next will be 16 plus 13, 29, and we keep going. So at the end, the cumulative frequency will be the total frequency. So we can say 6 plus 10, then 16, 16 plus 13, 29. So 6 plus 10, 16, 16 plus 13, 29. 29 plus the next frequency will give us the next value. And this is the solution. We call this the expanded frequency distribution. In our assignment, we can do only the class and frequency with the relative frequency. That's enough. But these are all the possible 5 columns we can get. We know how to get the class, the frequency, we count it, we find the midpoint, and the midpoint we say always is the average value of the lower limit and also the upper limit when you find the average. Then from there we find the relative frequency, which will be the proportion of each class. We can see the total is 1. So for example, if I'm here, the class between 19 to 30, my frequency there is 10. I divide 10 by 50, the total frequency, 0.2. Divide 13 by 50, you get 0.26. Divide 2 by 50, you get 0.04. When you add all these values, you should get 1. Then cumulative frequency, we go to the frequency. First value is 6. When we add 6 to 10, we get 16, so it's 16. When we add 16 to 30, we get 29. When we add 29 to 8, we get 37. When we add 37 to 5, we get 42. When we add 42 to 6, we get 48. When we add 48 to 2, we get 50. So this will be the conclusion of our video on how to construct a frequency distribution. And it's, again, a statistics topic. So this week, Unit 3, we are learning about statistics. We move from the discrete mathematics to statistics. So again, if you have any question, feel free to send an email, and thank you very much.